regional pattern of productivity in India. Indian agriculture is known for its diversity, which is mainly the result of variations in resource endowments, climate, topography, and historical, institutional, and socio-economic factors. Policies followed in the country and nature of technology that became available over time have reinforced some of the variations resulting from natural factors. As a consequence, production performance of agriculture sector has followed an uneven path and large gaps have developed in productivity between different geographic locations across the country. These regional variations have remained a subject of concern. The question pertaining to definition and measurement of productivity is always debatable among agricultural scientists, economists, and other concerned researchers. A simple calculation of agricultural production, method of production aggregation in terms of money are noticeable measurements of productivity for showing diversification in agricultural production patterns emerging in India. However, there is still a question among scientists whether total crop production produced by a piece of land is product of many factors like agroecological conditions of land, technological enhancement and labor employed for agriculture. In this lesson, let us examine the various inputs for production and their effects on productivity from the following headings. Productivity variations across regions, factors affecting productivity, pattern of agricultural diversification, changes observed due to change in productivity pattern, development and use of modern inputs. Productivity variations across regions. Generally, the level of agricultural development in a particular region is measured in terms of the output per unit of fixed factors of production. Therefore, land productivity is preferred as a measure of agricultural development. Spatial distribution of the districts across states and regions by their level of development detailed in table 2 reveals interesting geographical pattern of agricultural development across regions and states in India. About a half, 47.5% of the most developed districts in India are located in the northern region alone. Another 27.6% of the most developed happens to be in the southern region. Taken together, 3/4, 75.2% of the most developed group of districts are from the northern and southern regions. Only 5.5% of the highly developed districts happen to be from the western central region, which is the biggest of all regions area-wise. 62% of the chronically underdeveloped districts are located in the western central region, whereas the northeastern, northern, southern and eastern regions accounts for just 5, 10, 10 and 14% respectively. Further clubbing the districts in the top 2 and bottom 2 quartiles reveals another interesting pattern. While 38% of the developed districts in India in the top quartiles are located in the northern region, western central region accounts for 42% of the underdeveloped districts in the bottom 2 quartiles in India. This implies that the northern and western central regions are diagonally placed opposite on the scale of agriculture development in India. Dynamics of inter-regional pattern would be clearer by examining the distribution of districts across state. For example, all districts of Punjab fall in the top quartile of highly developed group of districts, whereas 50% of the districts in Jammu and Kashmir in the same region fall in the chronically underdeveloped category. Similarly, all districts of Kerala are in most developed top quartile, whereas almost half, 46% of the districts in Karnataka, another state in the same southern region, are in the least developed quartile of the chronically underdeveloped category of districts. Same is more or less true about the eastern region. Western Central region seems to be the exception in this context, as most of the districts in almost all states in this region are in the bottom two categories of the underdeveloped districts. Only very small, consisting of only 2 districts each, states or union territories of Goa, Dadra and Nagar Haveli and Daman and Diu are exception to this pattern. Information presented in Table 2 brings out that the inter-regional variations in level of development are more severe across states in India. On the one extreme, we have the state of Punjab having all its districts in the topmost developed quartile, whereas on the other is Chhattisgarh with none of its districts figuring even in the top 2 quartiles of developed districts in India. Similarly, besides some single district union territories, there are 10 other states, namely Bihar, Jammu and Kashmir, Jharkhand, Orissa, Madhya Pradesh, Manipur, Mizoram, Nagaland, Rajasthan and Sikkim having none of their districts in the topmost developed quartile of districts. Factors affecting productivity. Since the 1960s, there has been increased interest in regional disparities in agricultural development and crop productivity. Most studies argue that policies and technology are the key factors driving regional variations in agriculture. The Green Revolution in the late 1960s shifted the world's focus from increasing agricultural output through expansion of cultivated area to increasing it through higher yields. Yields were increased through the use of irrigation, fertilizer and new high-yield variety seeds, HYVs. Productivity of crop sector per unit of area and per worker is affected by several factors. Some factors which are considered as the most important are examined through a tabular analysis pattern of productivity per unit area and per worker, and factors like rainfall, levels of irrigation, fertilizer use and diversification towards high-value horticultural crops. The table also presents information on cropping intensity, which matters for productivity but which itself is affected by rainfall and irrigation. It is interesting to observe from Table 3 that crop productivity per agriculture worker in different categories closely follow land productivity through variation in land productivity is found to be somewhat higher than productivity of labor. Another interesting feature of land productivity is that it very closely follows variation in per hectare fertilizer use. Irrigation coverage and crop intensity also show increase with the increase in productivity. Area allocated to fruits and vegetables also show positive association with per hectare value of crop output. In the category of productivity, where per hectare fertilizer use was 537 kg, area under irrigation was 24% and crop intensity was 122%. In the average productivity category, fertilizer use increased to 101 kg, irrigation coverage increased to 146% and 34% area was sown more than once. Area allocated to fruit and vegetable increased from 2.3% to 5.7% as one moves from very low productivity districts to low productivity districts. Land productivity between average and bottom category show ratio of 1:2.49. Land productivity in top category was 128% higher than the average category. These results shows that per hectare labor use increase faster than increase in land productivity as we move from very low productivity districts to average productivity districts. Districts having very low productivity receives lowest rainfall 93.5 cm per year, whereas districts having very high productivity receives highest rainfall 150.7 cm per year. Rainfall did not show clear pattern in the middle categories. As can be seen from the table 3, effect of irrigation dominated small variation in rainfall. Even though the districts in high category get lower rainfall than the districts in average productivity category, but irrigation coverage in later is 15% higher than the former, which explains variation in productivity. Precipitation and temperature patterns in tropical and dry states have the largest impact on increasing food grain yields above those in temperate states like Uttar Pradesh and Madhya Pradesh. These estimates show that variation in availability of water either through irrigation or through rainfall cause significant variation in district level productivity of agriculture. However, fertilizer and diversification towards high value crops caused much stronger influence on productivity. Pattern of agricultural diversification. There have been significant changes in the pattern of agricultural diversification at the regional level. Within a region, smaller sub-regions or pockets of specialization in certain crops and crop groups have emerged. Farms do not remain diversified, and the usual notion of crop diversification as a risk management practice also belies. In the recent decade, diversification is increasingly being used to describe increase in area under high-value crops. As is evident from Table 5, there is a general decline in the share of cereals in the value of agricultural output in states barring Haryana, Punjab and Karnataka. In these states, the cropping pattern appears to be oriented towards cereals, especially wheat and rice. The share of pulses in the value of agriculture has increased in the states of Karnataka and Madhya Pradesh. In Karnataka, the area under pigeon pea and moong increased during the reference year. While Madhya Pradesh is the major pulse-producing state of the country, pigeon pea and chickpea are important pulses produced in most states. These pulses account for more than 60% of area under pulses in the country. Increase in the production of soya bean in Madhya Pradesh and rapeseed and mustard in Rajasthan is also reflected in the increased share of oilseeds in the value of agriculture in these states. In most of the other states, the share of oilseeds in agricultural output has declined. The cropping pattern in each state was compared between 1999-2000 and 2006 and 7 by using the index of crop diversification formulated by Bhatia 1965. It was seen that crop diversification had reduced from their 1999-2000 levels in the state of Bihar, Orissa and Jharkhand, while it increased significantly in Uttar Pradesh and a lot in West Bengal. From the Simpson's Index of Crop Diversification, SID, which showed diversification away from food grains, it was seen that in Bihar it increased since 1970-71, but after 2000 and 2001 it showed a decline. In Jharkhand it decreased. In Orissa, it reduced especially since 1995-96. In Uttar Pradesh, it increased slightly, whereas in West Bengal, crop diversification away from food grains increased tremendously. In West Bengal, Orissa and Jharkhand, maximum diversification of crop was towards oilseeds. in Bihar and Uttar Pradesh, significant crop diversification was towards plantation crops like jute and sugarcane, respectively. As is evident from Table 6, states have different levels of shares in their fruits and vegetables produce in total agricultural output. The share of fruits and vegetables is high in most of the eastern and northeastern states. Among northeastern states, Tripura has a share of 37%, followed by Meghalaya with 35%. Most of the northern and western states have a very low share in the produce of fruits and vegetables, with Rajasthan registering a share as low as 1%. In the northern region, Himachal Pradesh is an exception. Fruits and vegetables account for as high as 36% of agricultural output. In the southern states, the share of fruits and vegetables are around the national average of 17%. The corresponding figures for Kerala and Tamil Nadu are 18 and 20% respectively. Changes observed due to change in productivity pattern. In India, area allocation among various crops has shown a measure of structural rigidity that reflects the traditional character of Indian agriculture, wherein food grains have remained the predominant crop, accounting for 2/3 to 3/4 of the gross cropped area since the early 1950s. This also reflects the impact of the prevalent demand structure. However, within the food grain sector, substantial changes have taken place. Policy makers in India have been stressing the need for crop diversification to higher value crops as major strategy of agricultural development. This is because with a rise in per capita income, whereas the demand for food grains is likely to grow at a slow rate, that for oilseeds, fibers, sugarcane, livestock and horticulture products is projected to grow at a much faster rate. The planners feel that such diversification not only offers opportunities for raising farm income significantly, these are also likely to put less pressure on natural resources. The introduction of new seed fertilizer technology during the mid-60s resulted in substantially raising these yield levels of some of the major food grain crops like wheat and rice. Table 2.6. The seed fertilizer technology was primarily confined to wheat and rice in the mid-60s. Later on, technology spread to a number of crops like the coarse cereals, rapeseed and mustard, soybean, sunflower, cotton and sugarcane, etc. This combined with a positive price climate resulted in increasing area allocation to these crops. The new technology was able to impact on the yield levels of non-food grain crops like oilseeds, fiber crops, sugarcane and fruit and vegetables after some time lag, thereby resulting in significant cropping pattern changes over time. During the 18 years from 1962 to 65 to 1980 to 83, the process of cropping pattern changes was slow and halting. Food grains, which accounted for 74.7% of the gross cropped area in 1962-65, still claimed 73% of area during 1980-83. The shift from low-value coarse cereals and pulses to high-value wheat and rice resulted in increasing the share of food grains in the total value of output from 62.2% during 1962-65 to 68.74% during 1980-83. In the southern region, there was a substantial decline in the share of area under coarse cereals and food grains and some increase in the share of area under pulses, cotton, sugarcane, plantations and remaining crops. As in many states in the central region, Andhra Pradesh and Karnataka in the southern region also had large shares of their area under coarse cereals and pulses. Although rice dominated the cropping pattern in Tamil Nadu, a sizable portion, 22.4% of its cropped area was under coarse cereals even by 1980 to 83. The largest rise in output growth and yield was in the period from 83 to 93. This was also the period when input consumption shot up to the peak in India. There were substantial changes within the food grain production itself. Due to the rise in yield and the price advantage during 1965 to 80s, the share of wheat in the total cropped area increased from 8.9% to 13.7%. On the other hand, the share of coarse cereals and pulses recorded a notable decline. Development and use of modern inputs. Information on distribution of districts by the level of development and use of land area, labor, fertilizer, irrigation, tractors and tube wells, and availability of credit supplied by the scheduled commercial banks for agriculture purpose is detailed in Table 11. A close affinity between use of inputs and level of agricultural development in India is clearly evident from the information. Level of development measured in terms of land productivity and per hectare use of modern inputs moves in tandem with each other. There are 3 to 4 time variations across districts in use of modern inputs across highly developed and chronically underdeveloped districts in India. For instance, fertilizer use varies from a high of 239 kilograms per hectare of the net sown area in highly developed districts to as low as 57 kilograms for chronically underdeveloped districts. Intensity of tube wells in these districts is as low as 74 per 1000 hectares of the net sown area against 173 in the highly developed quartile. Assured and regulated supply of irrigation through tube wells, in particular, along with other time-saving and production efficiency enhancing machines and implements like tractors, facilitate intensification of land use. This is evident from the fact that high density of irrigation, tube wells and tractors enable the most productive top quartile of districts to use as much as 60% of their land area under double cropping. Compared with these districts, the proportion of the double cropped area in the chronically underdeveloped quartile of districts is as low as 19%. Differences in the level of agricultural development across districts are intimately related with the cropping pattern across districts. In fact, the use of modern inputs in general and fertilizers and irrigation in particular is closely related with high input intensive modern technology crops like wheat and rice. This is evident as more than half of the area in highly developed group of districts is under wheat and rice crops, while the developed top quartile group has 56% of their areas under high productive rice and wheat crops and high value condiments, spices, fruits and vegetables. The bottom quartile of chronically underdeveloped districts has as much as 56% of their area under low productivity groups of coarse cereals, pulses and oil seeds crops. Though cropping pattern is intimately related with the levels of development, yet some other factors seems to be at work for emerging inter-district disparities in the levels of development. This is evident from the variations in intercrop yields across the levels of development. With exceptions of F&V and C&S and pulse groups, there are not much significant intercrop differences in crop yields. very small intercrop variations in yield and very high intracrop differences in yield across districts seems to suggest that factors other than cropping pattern like access and choices of crops technology, capacity and capability of the farmers in exploitation of the available technology, agroclimatic constraints and agricultural environmental factors related with access, quality and efficacy of rural infrastructure may be at work for observed inter-district differences in development of Indian agriculture. With divergent cropping pattern, growth and levels of development, varied agroclimatic and environmental diversities, uniform development strategy may not resolve the problem of all the regions. With the change in cropping patterns in India in the mid-80s, the productivity also improved. During the period 70s to 80s, the combined cultivation of wheat and rice led to the spread of new technology to many new regions, Gujarat, Maharashtra in central region and Andhra and Karnataka in the south. For most of the crops, the percent share of leading producing states has increased during the reference period 1983, 2003 and 2006 and 7. This suggests an increasing trend towards specialization in agricultural production. Changes in the percent of gross cropped area also suggest a move towards specialization. There has been a significant increase in the percent of gross cropped area under fruits and vegetables. The role of modern inputs in inter-district differences is also evident from the comparative variations in the share of area, output and modern inputs across the districts categorized by their level of development. Cropping pattern in each state was compared between 1999-2000 and 2006-07 by using the Index of Crop Diversification formulated by Bhatia 1965. It was seen that crop diversification had reduced from their 1999-2000 levels in the state of Bihar, Orissa and Jharkhand, while it increased slightly in Uttar Pradesh and a lot in West Bengal.